Hello, everybody, and thanks so much for joining my session today. My name's Todd Golding, as the slide says. I'm a partner solutions architect at AWS, and I'm part of a team that's called the SaaS Factory. And that team helps organizations that are building or delivering or optimizing SaaS solutions on top of AWS. And obviously, just generally in the industry, we've seen a lot of movement to the container space. And certainly we've seen SaaS companies that are very much wanting to take advantage of container-based technologies. They like the sort of modernization story, the microservice story. There's just lots of goodness in the container sort of architectural footprint that is very appealing to SaaS organizations. So what we wanted to do as the SaaS Factory team was create some prescriptive content that could really help organizations understand what it means to design and build and create a SaaS solution running on top of a container-based architecture. And really that's the focus of this session today, is really to look at this sample solution and look at the moving parts of a SaaS architecture realized on top of, in this case, EKS. Certainly this is a lot of what we're going to talk about here is global to the container story, but we really wanted to focus in on one specific area and give you a really prescriptive solution just for that one area. So here you're going to see everything through the lens of what it means to realize this solution on top of EKS. Now, I will say this presentation is really targeted at a 300 level. So we're really going to focus more on what are the sort of architectural elements of that SaaS solution, what are sort of the key sort of design and architecture decisions we've made, and then we'll point you to the GitHub repo where we've actually got the working sample SaaS solution. And there you can go and download that solution and really open it up and look at the code and the details and the underlying bits to get a better sense for what it means to actually like build this end to end and see the code and how it works and how it orchestrates this entire experience. But hopefully that aligns with your expectations. So let's kind of dig in here a little bit. And before we get into the architecture, I definitely want to just look at like, what is it about EKS? What is it about containers that is so appealing to SaaS providers? Why the motive to go to this model? And certainly one of the reasons is this just whole notion of rapid scaling, right? If we look at a container-based model and just fundamentally how containers scale and how fast they can scale and efficiently they can scale, we find that this is a really good fit for a SaaS-based environment where workloads are very spiky, they're very unpredictable. And what we really don't want to be doing is over-provisioning environments, right? Building out all this infrastructure and building these scaling policies that are for like worst-case scenarios. And here, this is where EKS and containers give us a really good way to sort of build just enough infrastructure and have these more conservative scaling policies that rely more on the environment to just scale as needed. Another dimension of the container-based world that's really appealing, especially in the EKS space, is all the security sort of mechanisms we get. We see that we have a really rich set of constructs that allow us to build tenant isolation, realize tenant isolation strategies on top of EKS. So both IAM and AWS constructs sitting on top of EKS are used here to isolate environments. And then we just have all these other community tools and mechanisms that help us enrich the overall isolation story. Obviously, in any SaaS environment, we look at cost efficiency. We're always trying to align sort of tenant consumption with the actual cost of our infrastructure and environment. And this sort of relates back to the scaling policy part of this and the scaling efficiency. Because we scale more efficiently, we don't over provision, and we find that we're not sort of paying for a lot of idle infrastructure that's laying around and running. And so this is really sort of just a core value for SaaS organizations, and this cost efficiency really ends up being a real big benefit of an EKS environment. Community tooling, this is more of a broader statement that just in general, if we look at EKS, we find that there's a really rich set of tools constantly emerging. AWS is introducing new capabilities, the community is introducing new capabilities, and so we're constantly getting new tools and new mechanisms that will allow us to build SaaS on top of EKS and like introduce new data partitioning strategies, new isolation strategies, so on. And the last one here is more about the mindset of developers. To me, I'm always thinking about what does it mean as a developer now when I pick up containers and I move to EKS? Am I going to have to write my code differently? Am I going to have to think differently? And for me, at least, the mental model of developing inside of your classic maybe Java or .NET environment often moves very transparently with you to a container-based environment. And so you get a pretty natural sort of transition from one to the next. Yes, you're going to think differently because of microservices and because some of the more modern constructs, but a lot of your sort of language fundamentals and tooling fundamentals can move with you. Okay, now I want to look at the broader landscape of this solution before we drill into the inner workings of it. Because in any SaaS environment, we have all these sort of core values that are part of building and realizing a SaaS architecture on top of AWS. And what you'll see, in fact, if you look across lots of our content, serverless and other bits, you'll see this same sort of framework of moving parts, but each service sort of realizes them differently. So EKS certainly brings its own dimension of considerations to this landscape. But if we just look at it generically here, certainly we have multiple tenants coming in. Those tenants have to onboard. Now, in an EKS environment, and as you'll see as we dig into this solution, you'll see that onboarding experience has lots of unique moving parts to it. How do we set up our environment, how we create users, how we create the infrastructure for our tenants, has a very specific flavor inside of EKS, so we'll look at that. Certainly we need to authenticate users. How do we authenticate them? How do we get their tenant context and flow it into the underlying EKS cluster of our environment? We'll look at those bits there and what we did to sort of deal with the routing and the delivery of that JOT token into our EKS microservices. Then we'll look at actual application microservices, like what does it mean to build an EKS microservice, like the building blocks of our applications. What are the value systems there? What does it mean to build a multi-tenant microservice? And we'll look at how those microservices access data. So here we'll have examples of different data partitioning schemes, and we'll show you how a microservice in EKS leaves that service and in a safe way accesses the resources it needs to store or manage data or other resources that may be related to that service. And of course, as part of this, we'll also have to look at the tenant isolation dimensions of this. We have across these services that you see at the top, how do we keep one service from accessing another service? But also, how do we manage as we leave these services and we go to access other resources? How do we control the access to those resources as well? And so we'll definitely look at that. Now, the scope you see here is all we're going to cover in this particular session because of the time we have. But if you're looking at a complete sort of SaaS architecture, definitely going to look at like metering, metrics, analytics, and how you gather that data. And you'd also want to look at the DevOps and the management and operations story, right? How are we going to have visibility into what's going on with our tenants? How are we going to deploy parts of the system? How are we going to have that zero downtime footprint? And to me, that's the whole architectural footprint. So when you leave the session, even though we're not going to hit on those pieces, certainly think about how you're going to introduce those. Go look at the other content we have around those topics and consider all of that as part of your EKS architecture. Okay, so now we can start looking at what's actually in this, how did we build it, what sort of technologies and stacks are used here, and we're going to start at the client side of this experience. So if you look at this example here across the top, we have 3 different applications that are part of the EKS experience. On the left-hand side is what I'm called the landing page or the sign-up page. This is the page that's just the general marketing page where you market and bring visibility to your application. And this is where users can say, hey, I'm interested, I want to sign up. And they'll go through that experience and sign up for your solution, pick from the plans that are interested, and so on. In the middle is your actual SaaS application. And here we've got a really simple little SaaS commerce application with a few microservices that at least show off this. But more importantly, it shows off how you authenticate in this EKS environment. So it'll authenticate against Cognito, get that JOT token, and then send that JOT token through to our backend services. And then on the far right-hand side, you'll see the admin console. This is the admin console many of you will need as SaaS providers. And this will let you manage tenants, manage users, and it also has an authentication experience that uses Cognito. Now, these services all access a backend, and this backend is basically our EKS cluster, and that EKS cluster is basically broken down into 2 separate categories here. On the right-hand side, you'll see a set of shared services. These are the horizontal services that are used by all of our multi-tenant sort of design and implementation here. So here, registration, user management, tenant management, these are the services that will orchestrate what it means to introduce and manage and create tenants in our environment. And here you'll see this is where we will continue to add more services, billing and metering or metrics and analytics. We'll build this out into a much richer set of solutions, but that's where I mostly want that there as a placeholder for you to know this is where my this is where my shared services land. And then on the left-hand side are the services that actually make up your application. So here we've got an order service and a product service that are a simple sort of commerce service. You can imagine lots more microservices coming in here. But it's really important to understand these two separate domains, your application services versus these shared services. Okay, so now that we have this sort of groundwork and this framework for discussion, let's look at what happens when you actually go to the repo, you download the code, and you install it in your environment. What are you going to get when you go into the console and you look at it? So here you'll see we have the sort of basic things you'd expect. First of all, you're going to get a multi-AZ, highly available sort of architecture that is just the foundational bits of your EKS environment. And you'll see here we've got Route 53 at the top of this experience, and we've got an Nginx controller. We'll get into that whole routing bit in a little bit more detail, but that's essentially going to route the traffic into our EKS cluster as the client makes calls into the back end. And then you'll see our shared services. So we talked about registration, tenant management, user management. These shared services will get deployed into the EKS cluster. And then you'll see that they have dependencies. For example, registration uses the code pipeline. Tenant management uses DynamoDB. User management uses Cognito. And what we'll find here is that once we have all of this sort of provision, all the pieces are in place for us to be able to begin to introduce tenants into our environment. So when we look at introducing tenants in the environment, they're landing in the exact same infrastructure that we saw on the previous slide. It's essentially the same VPC, the same multi-AZ environment, the same routing. But now what we have to provision is each individual tenant, in this case, namespace. So what we've chosen here in our EKS architecture is to say, we are going to essentially deploy every single tenant into their own namespace. And based on sort of the isolation profile and the needs of that are common to SaaS environments, we believe that the namespace per tenant model is a really good model for this solution. There are other ways you could certainly approach the isolation, but we really think this is a really solid theme. And it's certainly an area that I think there'll be a lot of discussion around. But everything about the architecture that you see here is very much driven by this namespace per tenant model. So it's definitely an area you want to think a lot about as you look at building an EKS SaaS solution. So we basically provision all these microservices into this namespace per tenant. And now as we provision more tenants in this environment, they're just provisioning an additional namespace with all of the microservices here. So here you'll see that we're not really sharing any compute across these individual tenants, that each one is running its own set of microservices. Okay, so that's the underlying bits. Let's now look at like the end-to-end experience of what it means to actually onboard a tenant. Let's look at how these services that are getting introduced get orchestrated and by the different moving parts of our environment. So when we come into this system, you'll see that we come in as a tenant. We want to register. We hit that landing page that I mentioned earlier. Certainly, this is meant to be a self-service notion of onboarding. We also have in our admin console, we won't get into it because we don't have time, a way for you to internally onboard tenants if you want to. So if you don't have a publicly facing way to onboard, you can use that mechanism as well. The key takeaway here is that they both use the same underlying services and capabilities to bring those tenants into the system. But here we'll hit the landing page. We'll say we want to register as a new tenant. We'll fill out the registration form, put in our data about it, and then we'll hit this registration service. And this registration service is essentially responsible for creating all the infrastructure and all the configuration that's needed to introduce a new tenant into the system. In fact, if you look at our other content, you'll see this is a really common theme across that content, which is that there's always this one single sort of onboarding registration process that orchestrates a frictionless model for introducing tenants. So in this use case, registration goes out to user management. User management then needs to create a user in Cognito. So it creates the user pool, and we'll do user pool per tenant, and there's some ramifications of that we'll look at. Get the app ID, and then set up custom claims. The tenant ID and tenant role and tenant tier and all those things can go in these custom claims so that now when we authenticate a user, we'll see that we get a JOT token back from that authentication experience that is enriched with all of this tenant context data. We also have to create an actual tenant in our system because remember, we can have a single tenant that has many users. So we separate the tenant and the user here, and then the tenant and its attributes get stored inside of DynamoDB. So ID, plan, all the things about a tenant, plus some identity characteristics you'll see that we use later on as part of our OAuth flow and authenticating users. So this gets a tenant and a user into the system, but we also have to go provision those namespaces we talked about earlier. So here we go out and we actually orchestrate the creation of a namespace, the setup and the deployment of the microservices, and the configuration of any isolation policies. And when this is all done, you essentially have everything you need to do to get a tenant introduced into your environment. Okay, so we've talked a lot about this namespace provisioning experience and the importance of namespaces. So really want to go a little deeper on that and show you what really happens under the hood when you create these namespaces. So first of all, we've talked about this routing, and certainly we're using Nginx as our ingress controller that will route traffic to each individual namespace. I will say this was a subject of a lot of discussion in our team. Should we use an Nginx controller? What should we use? What is the routing scheme we should use? And we settled on this, but we also sort of acknowledge that this is an area where there are a lot of options, and you really want to think about this a lot, and it will affect the sort of fabric of your solution quite a bit. So pay a lot of attention to that, and as you pick the options that might be best for your solution. And then on the left-hand side, you'll see this is that registration process we talked about earlier. When we hit it and we want to go provision bits, the first thing we're going to do is go out to CloudFormation, provision a code build pipeline, and then that code build pipeline, when it executes, will essentially be responsible for orchestrating the creation of all of this namespace and the configuration of this namespace. So one of the things it does is run this build spec YAML, and it uses kube control, the tool that is essentially used by Kubernetes to configure and set up our cluster and introduce the constructs we need for our namespace. And you can see here the various things that happen in the steps: setup of the namespace, setup of the policies, deployment of the containers. All of this is sort of handled in the scope of this YAML file. But then also we have to do certain things specific to each microservice. So with each microservice, we want to set up its scaling policies separately. And potentially we also have to set up the ingress resource for each one. So here, this ingress resource is the thing that allows us essentially to route from that ingress controller to each microservice in our individual namespace. Now, the microservice configuration itself, if we want to dig into that, you'll see here that we have a deployment file. And this deployment file is a classic sort of Kubernetes construct. And this Kubernetes construct describes kind of what the microservice is. In this case, we're looking at an order microservice, and you'll see it tells you what the image is, it tells you what the port is, and so on. So this is the sort of basic configuration of our deployment of one of our microservices. And then we also have a service that is the how. Here, how do you get to it? How do you get to that actual service? And this service configuration here, you'll see defines the order service, but it defines the protocol, defines the port, and then maps to that target port that was defined. And so these two elements are really sort of fundamental to EKS and to Kubernetes as deployment constructs. And then the one additive bit that we have here is this ingress resource configuration. So here you'll see for the order service, you'll see that we actually set up a path, and we indicate for the order service for this particular tenant, this is the path you'll follow to get to that particular tenant. And this now establishes that routing that's essential to get the tenant to the specific resource within the namespace. Now, if you looked at this is per microservice, so there's an equivalent configuration that's for our product service as well. Okay, the authentication experience here, while I don't think unique to EKS, I did want to at least highlight what we did with authentication. So when you go look at the sample, you'll have a sense of what's going on. Again, we chose a user pool per tenant model, so that affected some of how we implemented this, and we implemented a full OAuth flow. And so here we have our commerce application. A tenant comes in, they have a subdomain, and that subdomain essentially identifies them, a really common strategy that's used in SaaS solutions. And now when we have this tenant coming in and we realize they're not authenticated, we actually have to figure out which user pool to authenticate them against. And so this is where we have to go out to our tenant management microservice, and we use the origin of that tenant to map them to a tenant, and then we go look up their tenant identity settings. So this is where we'll see the user pool, we'll see the app ID, we'll see those other elements that are essential to our authentication experience. Those will come back to the client, And then those will get put into an authorized library. And that's just sort of a development construct here, where by putting them in this authorized library, it sort of hides them away from us. It holds those settings for us. So now as we go and interact with the identity provider, there's a home for those identity settings. So now once those identity settings are populated, we'll go out to Cognatal, we'll authenticate. That will hand back a code. Then we'll exchange that code for a JOT token. And then once we have that JOT token, we can then pass it through to the microservices that we call in the back end. And now when that JOT token comes through, it comes through with all the goodness that we've baked into it. The tenant context, the role, the tier, anything we need is all baked into that JOT token. Now, I have talked a lot about the routing decision here. I thought it was worth emphasizing kind of the end-to-end routing experience here, just so you have a sense of the moving parts of what we've done here, because I do think it's a big part of this solution. You'll see at the top of this, we essentially have Route 53. We have tenants coming in, tenant 1 and tenant 2, coming in with different subdomains. And then those subdomains hit the Nginx ingress controller that we have here. And now, because when we provisioned our tenants, we provisioned an ingress resource for each microservice. Now, ingress controller will know how to route to each one of these targets. And you'll see here, each individual microservice actually has a separate ingress resource within the tenant namespace. And so this really sort of gives us a really clean way to connect the incoming traffic to the right sort of destination within a namespace. Now, we also need to look inside the microservices that we're building inside of EKS. Like, what does it really mean to build one of these microservices? And really, building a multi-tenant microservice inside of EKS isn't all that different than building a multi-tenant microservice instead of other environments. But how you sort of abstract away the details of multi-tenancy, how you hide them away, what the mechanisms you would use here are very much something you'll want to think about as you're building your microservices. Like, what is your way that you're going to deal with hiding away data access or hiding away logging and so on. And so in this particular example, in a sample solution we have here, the JOT token comes in. Obviously, it gets routed to our microservice via the ingress resource. Just wanted to highlight that point. And now when we're inside our microservice and it says, hey, I want to log a message, for a developer, we don't want them to think about multi-tenancy. We want them to just log a message. So they'll say log a message. But in the back end of our system, we really want to be able to get all this richness of tenant context out of these log messages. We want to inject tier and tenant ID and all this other information into our log messages. So here our log manager will go out to a token manager. It'll get back all this tenant context, and then it will inject that into our logs. So now on the operations side, if we're over an Elasticsearch or whatever tool we're using to look at logs, we can now search and filter by tenant ID or tier or other mechanisms. Now, the same sort of thought process applies to getting data, right? So if our microservice needs to go acquire data, for example, from a database, it's going to go out to the token manager. It's going to get that tenant context back from the token manager. And now when it calls through the data access layer will be responsible for, okay, how for this particular tenant, for this microservice, do I access data? And it'll apply all those policies there. So again, this is all about pushing sort of tenant awareness away from developers. Now in the sample solution, these are just reusable libraries. We're seeing things like sidecars and other things as options here that we might think about for surrounding these microservices with more interesting mechanisms for dealing with multi-tenancy. Now, data partitioning here in our example is pretty straightforward. The data partitioning, we just wanted to show a little bit of this. There's a lot more detail out in the SaaS Factory pages about data partitioning. But here we did want to at least show what it would look like running inside of EKS and using some of these constructs we've introduced. So on the left-hand side, you'll see we have an order microservice, and it's using DynamoDB and what we call a silo model. So essentially in a silo model, each tenant has their own table, and you'll see how we sort of access and manage access to that multi-tenant data in a per table model. And on the right-hand side, you'll see we have the product service. And the product service is deployed in what's called a pooled model. In this model, it's a single DynamoDB table, but the data for the tenants is commingled. So now we have to figure out how do we resolve based on the partition key, how we get to the data, and things of that nature. Now, if you were to look at the overall sort of tenant isolation story of this environment, you would see that we have tenant isolation really at multiple layers. First, I think we've talked a lot about the fact that at the namespace layer, we've fundamentally decided that tenants will land in separate namespaces. That's the first sort of consideration of our isolation story. But even if we have those separate namespaces, we have to ensure that one namespace can't cross the boundary to another namespace. So this is where we introduce a pod security policy. And that policy makes sure that there's no traffic that can go from tenant one's namespace to tenant two's. We also have to think about, as we leave these services and we go to get to data, how do we enforce isolation? So in our example where we said we had a separate order table per tenant, we actually have policies around those order tables that control access to them. So if tenant one is accessing the order table, it can't cross a boundary to the order table of tenant two. And we do the same also for the pooled resources that are here. So in product, where they're pooled, we have IAM policies that look at that partition key as a way of controlling access to the data. And if we look at what that really looks like in terms of inside those policies, if we crack one open and look at it, here you'll see an example of the policy for the order table. And if you look closely at this, you'll see that this is essentially saying, hey, if somebody's accessing this particular table, they have to be this particular tenant. So this is, again, where we enforce that, prevent tenant one from accessing tenant two's table. And then you'll also see at the Kubernetes level, we have these network policies, and the network policies are used to prevent the cross-tenant access. So here you'll see a namespace and a name for a policy, and this policy is used to enforce the cross-tenant access model. So this, again, sort of gets back to this theme where I say you have lots of constructs available into you inside of EKS to really build a robust tenant isolation story. Now, one last thing where we want to really hit on is just this notion of quotas and tiers. Often in a multi-tenant environment, we are offering different experiences to different tenants. So we might have a basic tenant versus an advanced tenant. And here we can use EKS and resource quotas to really define different experiences for those tenants. And then we can have different scaling policies as well. So essentially for each tier of your system, you can use these EKS constructs to define how you might throttle, for example, a basic tenant and enable greater access or greater throughput to an advanced tenant. Okay, so I just want to wrap up here and look at a few key takeaways from this. Hopefully you can see that generally just the EKS sort of experience and the tool set and the community all represent a really rich opportunity for SaaS providers. There's just a constantly evolving set of tools and mechanisms available to you here, and a lot of choices. That's the harder point, which is you do have a lot of choices here, and you've got to sort of decide what's the right combination of options for your particular domain and your particular problem. Hopefully the EKS sample solution will fill a lot of those gaps for you. Also, even though we didn't get to hit on this a whole lot, I hope it's really important to realize, like, you have to think about not just how these namespaces are isolated from one another, but also how we describe the different experience of those namespaces. We talked about resource quotas and things of that nature. As you're deploying these namespaces, connect them to tiers, connect them to tenant experiences, and define those experiences so that your system really provides a rich experience across different tenant types. Clearly to me, IAM together with the sort of native Kubernetes constructs really represents an opportunity to build a really rich isolation story for SaaS providers, and really think you should really get very familiar with those mechanisms and figure out how they can influence your isolation approach. And then this namespace model, if you're going to use this namespace model, we really want to see you investing in making that like a frictionless unified experience where it's very repeatable, very scalable, and it requires no touch. Overall, I'm hoping you can see that there's just a really big community within EKS and within Kubernetes that is continually introducing new capabilities. And I really encourage you to really stay up to date with what's going on, because you'll see new opportunities coming all along. I mean, we have using code build now, we're looking at Flux and some other ways, and GitOps is a way of deploying. So we're seeing our solution continually evolve, and you should definitely be paying attention to that. I did say I'd point you at a link at the end of the session. This is the link to the sample code that I talked about. When you go out there, here you'll be able to see a download, run, install, a full working example, and there's more documentation there and more detail on what this experience looks like. And then finally, there are some other sessions going on here as part of reInvent. I definitely encourage some of you to go look at like OPN 303 and GPS 304. Those really are looking at a new offering we have called SaaS Boost that I think a lot of you would find interesting. and there's some business sessions as well. But that's my session. I hope you got a lot out of this. I hope you have a good sense of what it means to build a SaaS solution on top of EKS, and I really hope you enjoy the rest of the conference. Thanks so much.